Hey everyone, welcome back to Recursive Engineering. Today we are tackling cool problem mobile numeric keypad. If you are into puzzle and coding challenges, you are in here for a treat. Alright, let's dive in. Picture this, you have a standard numeric keypad just like we grew up with, and you can move to only 4 possible direction: up, left, right and down, and star and hash are off limit, you cannot use that. For example, from 5 you can move to 2, 4, 6 and 8, and we are given a number n and we have to find all the possible unique sequences of length n. So for example, if my n is equal to 1, we know we can take 0 1 till 9, and if you sum up you will get 10. Let's visualize this here. Suppose for n is equal to 1, you can take 0 1 till 9. If you sum up you will get 10. If you take n is equal to 2, now you have to make a valid possible jump, and we know we have only 4 possible direction. From 0 I can move to 8, from 1 I can move to 2 and 4, and my unique sequence will be 0 8 1 2 1 4. In this way, if you calculate, you will get 36 as your answer. I hope you guys understand this now. Discuss brute force solution first. Our idea is simple. We will make a different recursive call from 0 to 9. We will take one iteration variable I. We initialize it with 1, and when it reaches till n, we will count it as a valid number. And as we backtrack, we will take sum of all the counts coming from the recursive calls, and don't forget to add all the counts coming from these various calls from 0 to 9, and at then we have to return our answer. Let's talk about time complexity. We know we are making 10 different recursive calls, so it should be like 10 into, and for every recursive call we are going till nth depth, and for every digit we have 4 possible directions to move. So we can say it should be in the form 4 raised to power n, and yeah, this is the worst case we are getting, and yeah, this is the time complexity we have. Often better way to solve this problem. We know, like in the previous approach, we made a recursive call from 0 to 9, and we are going till nth depth. We are branching into 3 and maybe 4. So can we think of an approach like where we can reduce the number of steps here? And let me take one example here. Let's say, suppose I'm taking this. Let's say for this 2, in the previous approach, I have taken this 2 and we made a recursive call here. Let's take this 2, and suppose I want to calculate till n is equal to 3. So I know my next moves will be 1 3 and 5. Now as we go down, my depth will be reduced. Now it's 2, and let me take this example of 1. I know for this one I have 2 and 4, and my sequence will be 1 2 and 1 4, and this is for n is equal to 2. Can I say, like, if I'm calculating for n is equal to 3 and I know as I go down my depth will be reduced, can I directly say that if I somehow calculate the sum for this, I know this is 2, and I directly use this here, and similarly for 3 and similarly for 5, and if we add these 3 counts, we will get for n is equal to 3 for 2. So what my intention here is, like, we first calculate for every n, and whenever the new n we have to calculate, we just need the previous counts for the respective moves. So let me take let me show you, like, how we can do this. And we know, like, we are moving in between, like for every digit we have 4 possible direction, and we are moving in between 0 to 9. So we can create one move array for this. We can create one moves array where we can define the next moves for that value. Like for 2 we can move to 3, 5 and 1. For 0 we can move to 8. So this is for 0 we can move to 8. So in this way you can make this moves array. And if you want to calculate for 3 or maybe 4, maybe for 5, you just need your previous n value for respective moves. And how we can do this, let me take this one dp array where we can define our columns as the different values from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And here we can in the rows we can show like this is for n is equal to 1, n is equal to 2, and till we are calculating for n till n, and we just need to have the sum of last row, and I can say this is my answer. As you calculating for like n is equal to 2, you just need uh, you you just need to check in this moves array for 0, and you have to check the previous counts for like for n is equal to 1, what is my my counts for these moves array in this for 0. Complexity for this approach, we know we have 2D matrix, and we have 10 columns and n rows, and for every digit we have a maximum of 4 moves, so it should be like big of 4 into 10 into n, and its approximate will be big of n, and my space complexity will be, so I'm using this 2D matrix, so it should be big of 10 into n, and it should be big of n. We already have moves array which where every digit represents its corresponding moves, and we have stored in this moves array. Let me take one dp matrix. It should be of data type long, and its row length should be n and column length should be 10. And let's fill our first row with all the ones. Let's traverse through this dp matrix. Let's start our I from 1. We will go till n, and let's initialize our j with the 0, and we have to go till 10. And we know there are digits where these numbers are occurring, like 00, 11, 22. So we need to have these kind of numbers, so we have to say like our current cell should be dp of my previous row, and we have to take this value. And for let's source this moves array for j, and we will say our we have to count all the corresponding counts in this moves array, and it should be at num in our previous row. And let me take one variable sum, and we have to traverse the last row, and it should be dp of n minus 1 j, and we have to return our sum. Let's compile this now. Yes, it is working. Let's try to submit this. Yes, it is working. If you like this video, please subscribe and don't forget to comment. Thank you. Thank you guys.